Hello guys, today we are going to see the leetcode question 404. Here we have to find the sum of left leaves. So in a binary tree, the leaves are those nodes whose left and right child is null, or we can say there is no child, or a child which do not have any node which do not have any child are known as the leaf nodes. So here is given the root of a binary tree. We have to return the sum of all the left leaves. So in the binary tree, we have to return the sum of all the left leaf nodes. That is, in this example, we have 9, one node as 9, other node as 15, and the sum is 24. So we have to return the answer as 24. So here the same is given. A leaf is a node with no children. A left leaf is a leaf that is the left child or of another node. So first we have to check for each node whether its left child is present or not. If present, then we have to make the recursive call for each left and the right child. First, we have to consider a single node. Then we have to traverse the left part of the node. If we find a leaf node, then we have to take a sum variable and add the value of the node to the sum. Then further we have to make the recursive call for the right part, and in the right part further the left part is the left node, and here we can see in the example the right part of the tree is 20. By taking 3 as the root node, we get 20 as its right node. Then further the left node of the 20 is 15, so we have to add 15 to the left node. So first we have to take the base condition. If there is no root, then we have to return 0 or return sum. Then we have to make a function and pass the root node as well as the sum by call by reference, such that the sum can be incremented globally. Then we have to check if no node is present, then we have to return. Then otherwise, if by taking any of the node as the root, if root left is present and the root left side, that is here this side, and root left right side, that is this side, both of them are null, then that root's left side must be a leaf node. So we have to add its value to the sum variable, that is we have to increment sum, in this case is from 0 to 9. Then we have to make the recursive call, and after this there is no root, so we have to return. Then we have to make the recursive call for the right part. So taking 3 as the reference node or the root node, we can make the recursive call for the right side. Then 20 becomes the root node. Then for 20 as the root node, we have its left child as 15. The same thing take place. The left child left is null, and the left child right part is also null. So we have to increment the value of the sum with this node's value, because this node is the leaf node and is the leaf node, so we have to add 15. So the final answer becomes 24, and we have to return this value. So first we have to check the code for this question. So here is the code of the question. First we have taken a sum variable to store the answer. If there is no root present, then we have to return the sum directly. Otherwise we have to call or make a function call to solve this problem, and at final we have to return the sum. Here sum is made or passed by reference, and if the base condition is taken, if there is no root, we have to simply return, and the return type is taken as void. If we have to check the condition, if there is left root of the node and root's left child, that is the thing is this is the node, this is the root node, its left child is null, and the root left right child is null, then it must be a leaf node. Then we have to add the value of the root's left child value to the sum. Then we have to make the recursive call for the root left, and then further we have to make the recursive call for the root right. Then in this condition, when root right is passed, then again root right gets substituted with root, and this node is considered. And if root left is present, then again this condition is run. If root left child is present and root left is null, this one, and left right is null, then we have to add the value of the root node, oh sorry, root left node to the sum. Then we have to return the final answer. Then again here after this there is no root, so we have to return all the left and the, then again when the right this recursive call is made, then we reach this node and whose left child is not present, so this condition is not satisfied and there is no root. After this we have to finally return from this and we have to finally return the sum as the answer.